For 71 and 72, I would start by finding the equation of these line segments. That's pretty straightforward. And then find the antiderivative of all of those. And you can see that these are all the antiderivatives. So for example, if we took the derivative of this f function, it'd be negative 2x plus 6 plus 0, which is negative 2x plus 6. All right, what to do next? Well, next let's use that f of 0 is 1. So that would be this interval and this interval. So when x is 0, the y value is 1. When x is 0, the y value is 1. Therefore, c1 is 1. And when x is 0, y is 1. So 1 equals 0 plus c4. So c4 is 1. In our piecewise defined functions, we've got our definition of f of x for our first intervals. So the next thing we'll use is the fact that f is continuous. Its derivative may not be continuous, but f is continuous, and that will be very helpful information in figuring out the rest of the definition of f for both of these. Remember that continuity means if it's continuous when x is equal to 2, not this function, this is the derivative, but if we had the function of f, we know that f is continuous everywhere on this interval. So if it's continuous at 2, that means the limit as you approach 2 from the left is exactly the same as the limit as you approach 2 from the right. And it's also equal to the exact value of the function at x equals 2. Well, we already know from the first one that as we approach 2 from the left, going from negative 1 to 2, and including 2, our function is defined as negative x plus 1. So right at 2, f of x is negative 2 plus 1, which is negative 1. Well, as we approach 2 from the right with this part of the function, it also must equal negative 1, and that's how we'll find our constant. So 2 times the x value of 2 plus this constant is equal to negative 1, so this constant is negative 5, and we have that part defined. Since 2 is already used for this part of the function, we won't use it here. And we might as well use 3. It's going to have to be used for either this function or this function. So we'll use it for this one. It doesn't really matter in the end because both of these expressions, as we approach 3 from the left and the right, will both be equal to each other. So it doesn't matter if we included the 3 here or in the third part. Okay, here comes the third part. It's just a constant. Once again, the idea of continuity will help us as we approach 3 from the left and as we approach 3 from the right. The f value must have the same exact limit. And it must also be equal to the f value when x equals 3. Well, we know that the f value when x is equal to 3 is defined by this function. 2 times 3 is 6. 6 plus a negative 5 is positive 1. So as we approach 3 from the left, the function is equal to 1. So as we approach 3 from the right, it must also be equal to 1. And it's the constant, so that defines it for the entire interval. There we go. That's how you would do a problem like that. So let's repeat this work for number 72. It doesn't matter if we include the 1 for this part or this part because they will be equal to each other there because the graphs are continuous. And as we approach 1 from the left or as we approach 1 from the right, the output should be exactly the same. So since I'm not including it there, we will include it here. And for this 3, it doesn't really matter. Let's go ahead and include it and not include it there. All right, let's find this constant. As we approach 1 from the left or the right, we'll get the same value. Well, as we approach it from the left, this value is approaching 1 squared plus 1, which is 2. So that means as we approach 1 from the right, this definition of f must also approach 2. And if that's approaching 2, when x is approaching 1, then this constant is 2 minus a half, or 1.5. Then for the quadratic part, we need to know its constant. Well, since the function is continuous, as we approach 3 from the left, and as we approach 3 from the right, we'll get the same thing. And as we approach 3 from the left, the y value, f of 3, is 3 halves plus 3 halves, which is equal to 6 halves, or 3. That means our parabola must also be equal to 3, or be approaching 3, as x approaches 3 from the right. So let's force this to be approaching 3. So as x is approaching 3, this is approaching a negative 9 plus 18, and the y value is also approaching 3. Remember, we got that from here. As x approached 3, this value was 3 halves plus 3 halves, which was 6 halves, or the y value of 3. All right, so we have 9. Subtracting 9 from both sides, we'll have negative 6 for our constant, and we're done. We've got our functions of f, just like the asked, and now we can do a quick graph of each of them.